All right, so the last and final unit we're going to look at is organic chemistry. And we're going to look at the basics, naming the different types there is, the different types of organic molecules there are. So in the 1800s, early 1800s, it was believed that organic compounds were produced by only living organisms, which is why it's called organic. In 1828, the first organic compound was synthesized in a lab. A German chemist synthesized urea. So what exactly is organic chemistry? It really is the chemistry of carbon. Carbon forms a vast number of compounds. The study of carbon compounds constitutes a large branch of chemistry known as organic chemistry. If you go in to take organic chemistry in college, like I did, it wasn't just one semester, which is a typical class. It actually went to Organic 1 and Organic 2. So you took it for a full year. There's that much that is involved with it, and it can go even farther. The chemistry of all other living elements or all other elements, is the branch called inorganic chemistry, which is what we were looking at a lot this year. Organic compounds outnumber inorganic compounds 10,000 to 1. So there's a whole bunch. Why is that? Well, carbon, which organics, the study of carbon forms 4 bonds and bonds readily with itself. So it can form up to 4 bonds with all different types of elements, including itself. And these 2 characteristics result in an element which can be formed a multitude of compounds. And another thing you can see right here is, along with forming different compounds, you can form different types of the same makeup of compounds. But first we're going to look at nomenclature. How do we call them? What do we call them? And you did see nomenclature at the beginning of the year when we were talking about ionic versus covalent. So now we're going to look a little bit more into like the covalent type, the nonmetal, including carbon. So compounds of carbon are numerous, that it's convenient to organize them into families that exhibit the same structures. So in 1892, we had the IUC, the International Union of Chemistry. These formulated the rules for the naming of organic. Now we have IUPAC. This is the International Union of Pure and Applied Chemistry, and it has updated the rules. So this is what we're going to look at when we're going to name them, or when you have to name them. First, you have a prefix. These are the substitutes. Anything that is added to it, like chlorine, bromine, stuff like that. Then you have the parent, and then you have a suffix, what type of family it is. So what is the parent? And we see these in our reference table, table R. Yeah, I think it's table R. Meth, eth, pro, but, pent, hex, hept, ox, non, deca. These are the parent. This is how many carbon atoms are in the longest chain. Simplest class of organic hydrocarbons, compounds composed of carbons and hydrogens only. We're not adding any of like chlorines, fluorines, any of that. Oxidants, no. These are divided into 4 general groups: alkanes, alkenes, alkynes, aromatics. We're not really going to look at aromatics, so don't worry too much about them. But again, you can find these in the reference table, table Q. And it does show you the general formula, which is great to help you figure out if something is saturated versus unsaturated. We'll get to that in a second. So alkanes, you can see right here, there are 2 carbons. So we know that's an eth, and the structural formula is ane, because it is all single bonds. If I've got a double bond, it's ene, E-N-E, and then triple bonds is ine, with a Y sounding like an I. Okay, so alkanes contain single bonds only, it is saturated, like underline, highlight, like bold it. It is saturated hydrocarbons, which means they're full. No more hydrogens or anything else can be added to it. General formula, CN, H2N plus 2. The N just stands for the number of carbons. So if there's 2 carbons, it'd be H would be 2 times 2, that's 4 plus 2 is 6. So there'd be 2 carbons, 6 hydrogens. All right, so structural formulas, you can see that right now. Methane, there are 4 hydrogens. Methane, ethane, propane, butane. You can see these are the condensed formulas right here. Don't worry too much about them. They're really good about giving them to you. They're straight chained alkanes. That means they go in a straight line like you see here. Most get to the next successive member of a homogeneous series. The same unit is added each time the additional CH2. Don't worry too much about this. It's probably going to be given to you. So naming this, you're going to be doing these on your own. I can't really do them with you right now. So naming this 1, 2, 3, 4, 5, 6, that's hex, all single, so hexane. Draw the structure and write the molecular condensed formulas for pentane and heptane. You do the same as you have here, only with those in the yellow pages. How many hydrogen atoms does octane molecule have? So oct means 8. So what you're doing with this, because it's an ane, 2 times 8 plus 2. 2 times 8 is 16 plus 2 is 8. So it'd be C8, H18. Is C9, H18 saturated? So 9 times 2 is 18 plus 2 is 20. This is not saturated. All right, branched alkanes. Ooh, I don't like that this is here. I do apologize for it. The alkanes listed in the previous table are straight chain hydrocarbons because all the carbons join in one continuous chain. Alkanes consisting of 4 or more carbons atoms can also form branched chains. So they have to have 4 or more. Branched alkanes, to name these, you find the longest continuous chain and use this chain as the parent name of the compound. Number the carbons in the longest chain beginning with the end that is nearest the substitute. This is, the branch. Wherever the branch is, you're going to want to put the number 1 to the closest to that branch. And that branch name, you're going to name it with how many carbons, just like we were seeing with the parent carbon. But it's going to end with YL, il. So if there's 1, it's going to be methyl. So like methyl pentane. So looking at this, I've got 1, 2, 3, 4, 5. This is pent, just like I was saying. There's that methyl. You're going to number these because you have to write the number that the branch is on. So this is going to be 2 because it's on the second of the branch, of the parent branch. 2, it's a meth. So 2-methyl pentane because it is saturated. It's single. Condensed formula, you can see there is a parenthesis after the second that just signifies that is where the branch is off of. All right, looking at this. Is a number needed in this case? There's 1, 2, 3, 4. Yes, you need a number to signify it's on the second, so it'd be 2-methylbutane. When 2 or more substitutes are present, list them in alphabetical order. If there is more than one of a given side chain, prefixes are used. So looking at this, I've got 1, 2, 3. I've got 3 methyls and 1 ethyl. And I'm going to number it down here, not up here. I want it up and down here because it's closest. So it'd be 3 ethyl, 2, 4, 5, and there's 3 of them, trimethyl heptane. Okay, looking at the following, I've got parent chain 1, 2, 3. So it's going to be bute. I want to say it's bute. Is it bute? I want to say it's bute. No, it's not bute. And I'm going to scroll back just so I can see real quick. 3 is prop, so it's gonna be prop. 3, it's on the second one, so it'd be 2,2-dimethyl propane. And then this is bute, 1, 2, 3, 4. So it's gonna be 2,3-dimethyl butane. Looking at this, I do apologize. This is kind of wonky. So this is supposed to be over here. So it'd be, I'm going to ignore this one at the moment because this is just a mess. But you can figure it out. Go 1, 2, 3, 4, 5. There's 5. So you know it's, I want to say pent. And it'd be 1, 2, 4 dimethyl pentane. And then write out the structure and condensed formula of 2,3-dimethylhexane. So you write out the hex, so 6, and on the second and third, you're going to put a methyl on it, or 1 carbon. Looking at this, number the chain and name. So 1, 2, 3, 4. That's 4 2,2-dimethyl butane. There's 1, 2, 3, 4, 5. That's pent. 2,4-dimethylpentane, and this is 1, 2, 3, 4, 5. 2,2-dimethylpentane. Isomers. So we kind of saw that on this one. Oh, sorry, I'll go back one. Right here and here. These are isomers of each other. Isomers just show that their molecule formulas would be identical, but the bonding arrangements are different. So you would still have the same number of carbons, only they'd be on different spots. And you did see this. This is exactly what we saw in the last one. These are structural isomers. They only differ slightly from one another in physical properties and where the carbons are actually located. More carbons have the greater number of isomers possible. Hexane has 5. Octane has 18. So there's more. The more carbons you have, the more you can do. Is this isomer or the same thing? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They are. Let's see. That's on 2, 3, 2, 3. They are the same thing. And then draw 2 structural isomers of N-pentane. So anywhere on pentane, just draw 2 isomers. So unsaturated hydrocarbons. Unsaturated, we've been looking at saturated. Those are all single bonds. Unsaturated means they do not contain the maximum number of hydrogens per carbon. A multiple bond within the structure can be broken to add more hydrogens to it. So alkenes and alkynes are unsaturated. Alkenes have a double, alkynes have a triple. Sorry, there should be 3 lines right there. So names of alkenes and alkynes are based on the longest continuous chain, just like we were seeing with a branch that contains the double bond. The location of the multiple bonds along the chain is indicated by the number of carbons in each atom nearest the end of the chain. So you are going to write, so I'm going to skip to over here. These have no number required because you have the same numbers. This 3, 2, and 3, you don't need a number. Anything higher, you do need a number. You're just going to say what it is after. So 1, 2, because it connects 2 and 3, so it's going to be 2-butene or butine, and this one is going to be 1-butine because it's right off the 1. So again, this would be 2-butine. This would this is 1, 2, 3, 4. 1-butine, and this is 1-pentine. Oh, butine, I was right. This is 1 propine or propene. This is propene. Sorry, this is 1-butene. Butene. Looking at this condensed formula, I'm not going to make you do that right now. Exercise. How many straight chain isomers can be drawn from hexene? Draw out octene to methylpentene. To which hydrocarbon does C9H20 belong to? So if you do 9 times 2, that's 18 plus 2. It is the alkanes, and it is saturated. All right, aromatics, you're not going to have to do them. Just know they're a planar ring. They are unsaturated again because you do have double bonds to them. And then geometry, don't worry too much about it. Just know that for the most part, they're going to be tetrahedral. For alkanes, alkenes are trigonal-planar, alkynes are linear. Hydrocarbon properties, because of the low polarity in the carbons and the hydrogens and relative symmetry, they're considered nonpolar, making them nearly insoluble in water, but soluble in nonpolar solvents, which means their melting and boiling points determined by London dispersion. In general, the larger the molecule, the higher the boiling point. For instance, the boiling point for methane is -161, which is why it's a gas. But for decane, it's 174, which is why it's a solid. Besides that, work on the worksheets, which are the 4 in the back. Do the rest of the POGIL. If you have any questions, please don't hesitate to ask, and I hope you guys have a great night.